Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we're going to understand a very important topic called as a boot sequence in a microcontroller. This is a very important topic, and in the most of the embedded interviews you can expect this question. If you're a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon and share these videos to your friends and colleagues. Let us start the video. Booting sequence in the ARM based microcontrollers. So first of all, guys, what do you mean by booting? What do you mean by booting? So first question you may get into the mind, what is called as a booting? So booting is nothing but the steps which are occurring from reset till your main program execution, till the starting point of your main program. The process which are occurring are software or hardware events which are occurring from the reset till you reach to the main function is called as a booting sequence. So booting sequence is nothing but in a microcontroller is a series of hardware and software events that takes place from moment power is applied until you reach to the main application program is called as booting. That means when you apply the power from that point till you reach the main program. So this entire process is called as booting process or a booting sequence. Okay, so I hope you are clear. The booting sequence in the microcontroller, most of the ARM and ARM-based microcontrollers, it is divided into four major parts. The booting sequence in the microcontroller, it is divided into four parts. They are named like this. One is called power on reset. Second one is called memory aliasing or a remapping. Our third one is called as a firmware booting, and finally the reset handler execution. There are four major steps are there in the boot sequence: power on reset, memory aliasing, firmware booting, and finally the reset handler. So four important things, and we will understand one by one. The first one is called as power on reset. The first major step in the boot sequence is called as power on reset. So very straightforward definition. What do you mean by power on reset? The power on reset means as soon you press the power button or as soon you press the reset button, the complete microprocessor and microcontroller circuits will get powered up. Okay, and once the power is supplied to the all components of processor and microcontroller, your circuits or your complete microprocessor will wait in a power on reset state only until the power or until voltage and current ratings meets with some standard value. Okay, this is called as power on reset. So before execution of any code, the hardware must ensure that system is stable and the internal circuits detects when voltage is reached to the safe and operational. That means when you apply the reset button, the voltage should reach to its optimized value or in a safe operating voltage and safe operating current. So whenever your processor or whenever your circuit reaches till that, your stage will be in power on reset stage only. Okay, so it will take some microsecond to reach to the stable level. Under power on reset is clock stabilization. This is also coming under power on reset. So that means, what do you mean by clock stabilization? So since we will be using a microcontroller and microcontrollers will be supplied with either from internal RC oscillator and external RC oscillator, external crystal oscillator, the microcontrollers will be getting a clock pulses. And this clock should be stabilized. That means processor will wait until the clock is getting stabilized. So if your clock is not stabilized, then you will be in a power on reset state. So processor or a microcontroller will wait for a certain number of clocks in order to get a stabilized clock and a stabilized frequency value. And until then your processor still will be in power on reset. This is the second point under power on reset. The internal circuit, either in an internal RC oscillator or external crystal oscillator, the CPU will wait, nothing but processor will wait with a specific number of clocks to ensure the timing is accurate. That means timing also should be accurate and also it should be stable. So until then the hardware circuitry will hold on a power on reset state only. Okay, so your voltage should get stabilized and clock also should get stabilized. Then only the processor will exit from the power on reset, or else your processor still will be there in a power on reset state. So this is called as power on reset. One is power on reset and one is clock stabilization. The second major step in a booting sequence in the microcontrollers and processors is memory remapping, or it's also called as memory aliasing. So what is this? We will understand with one simple diagram. So once power on reset happens, like once the voltage is stabilized and clock is also getting stabilized, the processor will exit from the power on reset state. So after power on reset state, the microcontroller will come out of the reset state and processor will start pointing to memory location 0x00. So this is your memory. Currently whatever you're seeing here, this is your memory block and this is your address. So currently whatever you're seeing, this is your address and this is your memory. Okay, so as soon a microcontroller or a processor exits from power on reset, and your processor will point to the memory location 000. This is your starting point of your booting process. Okay, so now here what it's supposed to start from 0x00. The processor has to execute has to start its execution nothing but the booting process from 0x0000, but there is a provision. So you can also start your booting process from any other part of memory location with the help of address remapper or memory remapper. So you can start from 0. This is the default address. If you are not changing the booting address, no problem. It will always start from 0x00 only. But for a different in a real time, it may require sometimes we have to start booting from the different memory location. For that purpose, they have given a provision to change the booting address. So instead of 0, you can start it from either from 20004000 or 200500, like that. You can change the booting sequence from any other part of the memory location with the help of address remapper or with the help of memory remapper. This process is called as memory aliasing. By default, you can start from 0, but it is also possible to change the booting memory location to any other part of the memory with the help of a remapper circuit, and this process is called as memory aliasing. So this is what here we have kept it. The 0 address can also remap to any other address in the address space with the help of remapper hardware. So this remapper hardware plays a very important role. So this plays a very important role in order to reallocate the booting address. The processor still looks at 0x00, but now the remapper hardware is having a window that can change the starting address of your booting. So 0 by default it will be 0, but it is also possible to change to any other memory location. So this is going to result in a booting or execution from a different address space from the different application. So this process is called as memory aliasing. That means it is not necessary to always start from 0. You can start it from any other point or any other peripheral also. The booting you can start, and this process is called as memory aliasing. I hope you are clear with the second major step called as memory aliasing or memory remap. The third major step in the booting sequence is called as a firmware booting. So this is the third major step in the booting sequence called as a firmware booting. So what is this firmware booting? So here also we have two major steps. One will be boot selection, and the second one is called as stack pointer initialization. There are two major things will come. One is called boot mode selection, and second one is called as stack pointer initialization. The first one is called as boot mode selection. So before going to the booting processor, the microcontroller has to select the type of booting, or nothing but boot from which part of the memory you have to boot, whether you have to boot it from the main flash memory or from the bootloader or from the SRAM region. So there are three different parts from the three different memories you can boot. One will be flash memory, one will be system memory, and one will be your SRAM. And this selection can be done by two hardware pins. Those pins are called as boot 0 and boot 1. These two pins are going to decide from which point or from which memory you have to boot. So like boot 0 and boot 1, 0x your flash, 10 system memory, and 11 it is SRAM. Nothing for debug purpose we will use a 1-1 combination. So this is what here we are explaining. After memory aliasing stage, the processor takes the boot mode selection with the help of pin configuration. There are two port pins are defined, boot 0 and boot 1. With the help of boot 0 and boot 1, we can select from which part of the memory we have to start a booting, whether from a main or from the system memory or from the SRAM region. So this is called as boot selection under firmware booting. The next step under firmware booting step is called as a stack pointer initialization. Okay, so the previous stage we have selected from which part of the memory we have to boot. Then now we are going to initialize the stack pointer. So now you can see this. This is my memory, and my processor is pointing to the memory location 0x000. This is my. Let us assume. Let us not go with the remapper here. Let us start from 0x00 as a default address. So when you're pointing to the 0x00 address, it will have one pointer address, and that pointer address will be pointing to the stack pointer. Okay, so that means, so whenever your processor is pointing to 0x00, there will be an address. That address will be moved to the stack pointer. Usually it's called as MSP, and MSP stands for main stack pointer. The address which is present here, that will be moved to the main stack pointer, and this main stack pointer is going to act as a stack pointer of your stack. So now the stack top is initialized, so that is nothing but stack pointer got initialized. So this is the second major step in the firmware booting. The program counter is loaded with address 0x00, that's what I told, and memory address pointing and memory address pointed by the program counter will be loaded to the main stack pointer. That means this one 600, whatever you're seeing, this address will be loaded to the main stack pointer. And from this main stack pointer, from this address, nothing but from this address, both stack and stack pointer will get initialized. I hope you are clear with this. So next important sequence under firmware booting is reset handler execution. Okay, so now what happened in the previous step? In the previous step, the stack pointer is initialized, and now the program counter will be getting incremented to the next level, next memory address, that is nothing but 0x00 here. So currently whatever you're seeing here, so this is my 0x00. Now the stack your program counter will point to 0x004. So this 0x004 is the address where your reset handler address is defined. Okay, you can see here. So this is in this memory location, reset handler address is going to be defined. Okay, so from this the program counter will be loaded with a reset handler address, and program counter will start executing reset handler. Now you can see here what is going to happen. So now whenever you are pointing to 0x004, this is a reset handler address. Now the program counter will be loaded with this address, and processor will start executing your reset handler. The reset handler is the actual first step for your booting process, and from that point your main program will start executing. You can see here. So PC, after pointing to 0x00, program counter will be incremented to the next address, that is 0x004, and the address which is present in 0x004 will be your reset handler address, and from this program counter will get loaded with this address, and processor will jump to the reset handler, and from this reset handler we are going to initialize your vector table. What are the different things we're going to do in the reset handler? The main important thing is we're going to initialize the vector table, and we're going to initialize the stack pointer, different stacks, and also we're going to initialize some default values for your registers and some of the memory location. So the reset handler is the first actual main booting entry point for your booting process. Actual booting will start from reset handler. The fourth major step is called a reset handler execution. So now in the previous state what happened? So we have reached to the reset handler. So here this is the third step in the under firmware booting. The first step will be boot selection, second one is a stack pointer initialization, and third one is your boot jumping to the reset handler. These three major steps will come under firmware booting. Now the fourth step is called reset handler execution. So we know that already in the previous slide, we loaded with a reset handler address, and processor will jump to the reset handler. So what are the different things will occur in the reset handler? That also we have to understand. The first important thing, the reset handler in the ARM based microcontroller is considered as an entry point for firmware. That's what I told you. So this is actually the first point of your booting process, the software booting process. This value of the reset handler in the vector table basically points to the actual. That means, so here you're going to take a reset handler address and you're going to jump to the reset handler, and in the reset handler you're going to perform different initializations and some of the default configurations we are going to do, and later we will jump to the main program. So what are the different functionalities your reset handler will do? So the first important thing, like in the reset handler, the first major step is we're going to initialize your stack, and already stack pointer got initialized, and also we're going to initialize stack here. What will be the size of your stack? What should be the memory location? All those things we're going to initialize with respect to stack, and also we're going to initialize CPU registers as well. That is the first major thing. Second major thing, during this reset phase, we're going to copy the memory from the flash to the RAM. That means the booting sequence will be there, will be available in the flash memory, and we're going to boot, and we're going to copy from flash memory to the RAM region. And also we're going to initialize some of the segment, nothing but your BSS segment will be getting initialized with 0, and the boot code from flash to RAM we're going to copy, and also some of the initializations for your peripherals, maybe ADC, DAC, or interrupt vector table. All those things we're going to including interrupt vector table also is getting initialized in the reset handler. If there is any memory management unit, or if there is any memory protection unit, if it is available, that also get initialized during your reset handler. Okay, so upon doing all those things, the main program will start executing. After doing all initialization in the reset handler, so the processor will jump to the main program. So from the main program, our user code will start executing. I hope you are clear with the concept. So if you feel this video is an informative video, please click on like button, subscribe my YouTube channel, click on bell icon, and share this videos to your friends and colleagues.